Hi guys, welcome to lesson 24.3 about logarithmic equations. This one is going to be in your Springboard book on pages 376 and 377. You'll want a pen or a pencil and your calculator because we are going to be solving logarithmic equations. Okay, so let's get started. So our learning targets are that we will solve logarithmic equations, identify extraneous solutions to logarithmic equations, and then use properties of logarithms to rewrite logarithmic expressions. So first here it says equations that involve logarithms of variable expressions are called logarithmic equations. We know that. You can solve some of these logarithmic equations symbolically by using the concept of functions and their inverses. So remember, their inverses are exponents or exponential functions. Since the domain of logarithmic functions is restricted to the positive real numbers, it is necessary to check for extraneous solutions when solving logarithmic equations. So if you don't know what an extraneous solution is, it is a solution that arises from a simplified form of the equation that does not actually make the original equation true. So we'll be plugging back in to check for those. Okay, so example A, this is your first one here. It's asking us to solve log base 4 of 3x minus 1 equals 2. So again, Springboard does this a little bit differently than how I would do it, but what I would do here is just convert this to an exponential function, and then from there you can solve. Okay, so let's go ahead. We're going to look at these three examples that are on page 376 for you. We're going to look at those on the next page. Okay, so your first step is to isolate the logarithm. So right now, this is the entire logarithm by itself, so it already is isolated. Okay, then your next step is to convert that to an exponential. So that's going to look like 3 as the base to the 5th power equals x minus 1. Well, now we can figure out what 3 to the 5th power is if we go to our calculator, 3 caret 5, and then press enter. We're going to get 243. So we're going to replace that 3 to the 5th with 243. And then we're just going to solve for x. So we would add 1 over, and we would get that x equals 244. Okay, and now your last step here is to check for the extraneous solutions. So we would plug that in. So log base 3 of 244 minus 1 equals 5. So we could do that in our calculator. If we go math to log base, and it was log base 3 of 244 minus 1, and press enter, and look at that, it equals 5. So we checked our work, it is true, so we are good to go. Okay. Then let's take a look at part C over here. You guys are going to do part B. So part C, this is your logarithm, so the natural logarithm of 3x. So that 4 out front needs to be, we need to get rid of it in order to isolate. So this is 4 times the natural log, so we're going to divide by 4 on both sides. Oops. So that'll cancel and leave us with the natural log of 3x, and then 8 divided by 4 is 2. So now remember, when we have the natural log, we can assume that the base is e, okay? So now when we go ahead and we convert this to an exponential, step 2, it's going to be e squared, e to the 2nd power equals 3x. So again, I can do this in my calculator. E squared would be 2nd, and then press this ln button. So you get your e squared, enter. And that's going to be 7.389. And then set it equal to 3x. And now we need to solve for x, so we need to divide by 3. So I'm going to go back to my calculator and just divide that answer by 3. And we should get 2.463. Whoops. So x equals 2.463. And again, we could plug this in. When you have the natural log or the base e, you will get a decimal. So when you plug it back in, you won't get the exact same answer, but we could do 4 times the natural log of 3 times 2.463, and it should be about 8 when we do that. So 7.99999, so yes, that's about 8. It's because we rounded our decimal. That's why it's not exact. Okay, so yes, we know that that is the correct answer. So we can check that off, we did it. Okay, so now I'd like you guys go ahead and try part B. Okay, so hopefully you paused the video and you should get, you convert it to an exponential, so 2 to the third power equals 2x minus 3. 2 to the third power is 8. Then you have to add the 3 over and divide by 2, and you should get 5.5, and you should have checked, and it is good to go. So you are done. Okay. All right, moving right along. Here's another example. This is also in your book, where you need to solve, and it's log base 3 of 2x minus 3 equals log base 3 of x plus 4. Now, these problems are super nice because when you have logarithms on both sides of the equal sign that have the same base, you can really just ignore them. And then what they did here is set those equal to each other, what's left. And so 2x minus 3 equals x plus 4. All you have to do is subtract the x over, add the 3 over, you're solving a linear equation, and you get x equals 7. Okay? And again, in this case, you should plug back in, which is what they did here, to check the work, make sure it's not extraneous, and you get log base 3 of 11 equals log base 3 of 11, so you know you're good to go. Okay, so that's good. All right, so let's try some of these in a second. That was this example B here, and we're going to try some of those, but let's take a look at example C, okay? Because in example C here, you have to use your log properties that we already learned about. Okay, so if you can tell here, this is log base 2 of x plus log base 2 of x plus 2. So since those have the same base, what you need to do is condense. Do you guys remember doing the expanding and condensing? So you need to use the product property here to write this as log base 2 of x times x plus 2. Okay, because remember, addition and multiplication went together with the product property. And then you can set that equal to 3. And then it's just like those first problems we were doing where you would convert to an exponential and then solve for x. Okay, so we're going to do an example like that on the next page. All right. Cool. Let's go ahead and try some of these. Okay. So this one first is exactly like what we were doing on the first page. So we would convert this to an exponential. 6 to the first power equals 3x plus 4. 6 to the first power is just 6. Oops. Okay. So 6 equals 3x plus 4. You would have to subtract your 4 over. And you would get 2 equals 3x, and then you have to divide by the 3. And you get x equals 2/3. Okay, so you can go ahead and plug that in to check. So log base 6 of 3 times 2/3, which would just be 2, plus 4 equals 1. Okay, so let's go ahead and plug that in. Math. Log base 6 of 3 times 2/3 plus 4. And it equals 1, which is what it said it should equal. So we know we are good to go. In case you can't see that, it does equal 1 over there. Okay, this next one, that's like example B. So it's log base 5 of 7x minus 2 equals log base 5 of 3x plus 6. So we would go ahead, because the log base are the exact same on both sides, we're just going to cancel them out. And this would be 7x minus 2 equals 3x plus 6. And so now we just have to solve for x. So I would subtract this 3x over. I'm left with 4x minus 2 equals 6. I'm going to add the 2 over, and I'm left with 4x equals 8. And I'm going to divide by 4, and I'm left with x equals 2. Okay, now again, I want to check my work by plugging it back in here and here. So that would be log base 5 of 7 times 2 is 14. 14 minus 2 is 12. Okay, and then here, log base 5 of 3 times 2 is 6, plus 6 is also 12. So we're good to go there. So x equals 2 would be your answer, because these match up. Okay. Then very last one here, this is an example where you need to combine or condense first, because we can't just go turning this into a into an exponential. Okay. So there are actually two ways to do this. The first way is you could combine by saying natural log of, we know subtraction means division, so we could do 10 over 4x minus 6 equals 0. Or what we could do is add that over. So I'll show you guys this way first, and then I'll show you the other way. But what we would do here now is, because we condensed this and all we did was write the 10 over the 4x minus 6 because of the subtraction. So now that we condense this, remember the base is e. So we can convert this to an exponential. So it would be e to the 0 equals 10 over 4x minus 6. Remember, anything to the 0 power is 1. So e to the 0 is 1. And then how do we solve for x here? Well, we want to get rid of this fraction, so I would multiply both sides by the 4x minus 6. And that's going to cancel on this side and leave us with 4x minus 6 times 1, which is just going to be 4x minus 6, and leave us with it equal to 10. And then I would add the 6 over, so 4x equals 16, and then I would divide by 4, so x equals 4. Okay, and I can check my work if I plug that back in. Natural log of 10 minus natural log of 4 times 4, which is 16, minus 6, which is 10. So natural log of 10 minus natural log of 10 is 0. Yeah, that would be true. Okay. Now, the other way I was going to say real quick that you guys could do this as well is you could use our other method, which would be natural log base 10 minus natural log of 4x minus 6 equals 0. Because it's equal to 0, you could just add this over. Okay? Only because this other side was 0, though. Okay, so then you would have natural log of 10 equals natural log of 4x minus 6 would be on the other side because we added it over. And then because you have the same log with the same base, remember both of these are base e, on each side of the equal sign, you can cancel those out and just set what's left equal to each other. So the 10 equals 4x minus 6. And that's exactly what we were left with here. 10 equals 4x minus 6. So this way you would also get x equals 4. Okay, so it's almost like we kind of learned two different methods here today. And then we also learned that we might have to use our logarithmic properties to help us out as well. Okay, so that's it for today. If you have any questions, please leave them here or bring them to class tomorrow. Have a good one. Bye-bye.